Hello, everyone. I'm here tonight with Stefan February from OverNode, and we're just gonna talk about OverNode and kind of have a little QA of the inner details of how it works and see where things go. So, welcome, and you want to kind of just start with an overview of kind of what OverNode is, and then we'll kind of dig in from there.
Yeah, sure. So the idea of OverNode, in one form or another, it's sort of been gestating in my brain for a really long time. I would say almost 10 years, maybe even more. And it really goes back to the time when we had peer-to-peer streaming services for music sharing, right? This was in the early 2000s, but then things sort of died down. By the time Bitcoin came around, I was pretty much done with peer-to-peer stuff. I thought, you know what, another peer-to-peer thing, I'm not interested. But then about 10 years ago, 10, 12 years ago, I sort of started getting interested in distributed computing and peer-to-peer networks again. And in particular, the idea of delay-tolerant networks. Delay-tolerant networks I'm interested in because I had this crazy idea that I wanted to essentially create a small little app that would, and I called it SneakerNet at the time. For those who don't know what SneakerNet means, SneakerNet is an old term that was used to refer to when we used to, if you take physical media like a floppy drive, or I guess now a USB stick, you stick it in your computer, you put the data on there, and then you walk it over to another person's computer and you stick it in there, right? So the idea was to basically build a distributed SneakerNet where a guy in a village in some rural place could essentially cycle the 10 kilometers to the nearest town with a mobile phone and essentially download stuff onto his phone, go back to the village, and magically the information would disseminate, right? It's a little bit like the mail service used to work back when we still were using physical mail and post offices.
Yeah.
And but the idea was to do this with data and to do it in a way that, and this particular thing is essentially called the delay-tolerant network. The idea that I can send something out to you, David, and it doesn't immediately get delivered. It goes somewhere into a store and forward service, and it will eventually find its way to you, or it won't. You know, it's sort of you pray that it gets there. OverNode tries to be a little bit better than that and actually tries to give delivery guarantees because we're more connected. But because it operates primarily from the person's mobile phone and there are no backend servers that I operate specifically for the purpose of providing connectivity between the devices, I still want to have delivery guarantees. I still want to have some notion of the liveness of data.
Mm-hmm.
So that idea of SneakerNet sort of moved into, okay, we have pretty powerful phones these days. What can I do today to not just make SneakerNet viable, but also solve a pretty big problem that I've seen persistently happen with not just peer-to-peer networks, but in distributed systems in general, which is the problem of altruistic nodes operating on the network, right?
Yeah.
So yeah, that's sort of my overview of it.
So I guess let's start kind of at the network level itself. Is this like its own peer-to-peer network? Is this something built on libp2p or something else, or like the actual? So when you're running actually, let's take a step back even further than that of like actual use cases. I'm a user. I'm part of some community that's doing something. There's some overlay on Bitcoin that different people who would be my peers have different knowledge about what's on what marketplaces, what NFTs are on what marketplaces somewhere. So I want to be able to, let's say, I don't even know that my example's on the right path here. So let's let me have you kind of take into like an example use case that's like real world scenarios or where we would be going scenarios for who is the user.
Right. I think that there are probably a lot of different use cases that I've sort of envisioned, and most of them tend to be the traditional use cases that we see today, except in the absence of a backend server. So this was the problem that I was trying to solve. Primarily, it's a problem of the data plane. How do I make a data plane that operates in a delay-tolerant fashion within a mobile-first environment and still give a good user experience to the extent that people don't notice that there is actually not, that Stefan isn't operating a backend server himself, right?
Yeah.
And the first thing that I'm actually building out to prove that the proper functioning of the data plane is a simple group chat application, similar to the way that Signal operates, or Telegram or WhatsApp operates, right? And that is just to ensure that I can essentially form a social network within a delay-tolerant network and have it actually operate in a regular fashion. There are additions to this, because once I'm able to actually prove, or once I was able to prove out, I should say, the data plane that it operates, that I can replicate data between peer-to-peer devices in this manner. The next step was essentially just to figure out, okay, what else can I do then? Well, I can make a marketplace, meaning that I can create I can essentially have a shop that I create on my mobile phone, where
Can
I
we
actually,
sorry.
Sure.
Can we actually slow down and like drill in a little bit on that group chat concept, the Signal replacement of?
Yeah.
Okay, so let's say some community exists. There is some group that already exists out there, and I want to enter that group, or they want to invite me into that group or something. And I assumably, I mean, there is some store and forward process going on between the members of that group. So I guess, is there some either kind of some indication amongst communication on the peer-to-peer level that the members of this group that need to have received this is like, how do you, I guess, let's dig a little deeper into what's actually happening to make that store and forward process work.
Absolutely. So at a really high level, what essentially happens is, so I started off by saying that Stefan doesn't operate a backend server, and that was deliberate, because it still doesn't mean that there aren't cooperating nodes on the network that assist in the movement of data. It's just that I'm trying to make sure that I properly communicate from a technical point of view, that these cooperating nodes, which have specialized functions within the network, are still peers, and they could also be operating on a mobile device. They can essentially be operated by anybody on any device, essentially. But there are specialized nodes on the network, which in the old Skype days, they would be called something like super peers, because they had a specialized function within the way the network operates. In my case, I've got one type of specialized node at the moment called the store and forward server. So apart from the specialized functionality that exists within the mobile phone, where you have peer-to-peer connectivity, you also have store and forward servers. And I should say that there are bootstrap servers for the peer-to-peer network as well.
Yeah.
Right? The bootstrap service in the peer-to-peer network, which allows people to, once the mobile phone starts up, or once the application starts up, you go to the bootstrap server. It has something called the distributed hash table, which essentially is a way of discovering other peers and whether or not what their addresses are, and to help you with connectivity establishment, essentially, especially when it comes to doing things like NAT hole punching, right? So the process starts with the application starting up on the mobile, announcing itself to the network in the bootstrap server to basically let the rest of the network know that it's live. The live status gets essentially gossiped into the network amongst all of the most of the nearest neighbors in the DHT. So because of the way that Kademlia and Chord style DHTs, and in my case, I'm using Kademlia in particular, because of the way because of the way it works, your node presence doesn't get announced to everybody. It gets announced to a subset of users on the network according to something called the nearest neighbor algorithm. And the nearest neighbor it's a question.
Oh no, I was just going to ask you to restate what that protocol was, or is that a service or a network or a protocol?
This is something inherent to the way that distributed hash tables function, like the Kademlia distributed hash table function.
Kademlia?
Yeah, Kademlia.
All right.
Kademlia is just, so the notion of a distributed hash table is the idea that I can have a key value store that is distributed and replicates its state amongst a number of different peers. And when you take this notion of a key value store that you can replicate amongst a number of different peers, and that automatically replicates its state, you want to do a couple of things. You want to ensure you run into some very hard computer science problems if you end up trying to make it fully connected, where every peer knows about every other peer. More than 25 years ago now, folks figured out that a better way of managing the state of the distributed hash table was by using first something like the Chord, C-H-O-R-D. So there's a really good academic paper, very easy to understand, on Chord, C-H-O-R-D, which talks about how to do something called let me remember the phrase now. It's just leapt out of my head. You're essentially, it's modular clock arithmetic in a network space where you essentially run through the nearest neighbor algorithm. And the exact technical term that would be Googleable absolutely escapes my brain. It'll probably pop in a second. But the idea is, right, that within this distributed hash table, you have it's a key value store, and since it is the primary means by which you bootstrap, it is the first thing that I would do with my application to announce my address of some sort, IP address, but because it's a key value store, maybe I have a long-term stable moniker, call it Stefan, that goes into the key side of the hash table, and then my current IP address goes into the value part, and that gets updated as and when when these change, and then you can have a protocol for how you communicate with the DHT or the Bootstrap server, how you communicate things like presence, you're joining, you're leaving, you're connecting, and then the Bootstrap or the DHT itself has this notion of not everybody needs to know about everybody, but if you have a way of essentially having the ability to calculate a distance function between all the nodes, then you can, every node that you see, you do a couple of things. You first see, okay, how close is this node to me? In the notion of closeness is not a geographic notion. This notion of distance,
number of hops, kind of thing.
Not even hops, not even network hops. It is literally a distance derived from the number, and I almost had the word for what that is. It's a notion that's derived from the actual. Let's say my name's Stefan and David. You basically are the two values that goes into the key. So I would like to only keep the 5 nearest words to Stefan and David. There is another way of doing a distance between these 2 words, something that computer scientists might know about, which is the Hamming distance. The Hamming distance is sort of a letter, see how it's a test of similarity between the two words in the alphabet by basically checking the interletter distance in the alphabet and then figuring out a little algorithm, right?
Yeah.
So you essentially create a mathematical, repeatable, deterministic way of always having a number resolved from how distant these two words in the key value, the keys are from each other. And when you see a new one that's closer in naming to the one that you already have, you chuck it out and you replace it with a new one. Now, this is an oversimplified way of describing constant hashing. Yes, that is the thing that I was looking for. It's called simple term, constant. It's, yeah, I'm pretty sure that that's the term, and that I didn't just cross my wires in my brain. Consistent hashing, not constant hashing.
Yeah.
Consistent hashing. So there is something called a consistent hashing algorithm, which, similar to the Hamming distance, calculates this numerical distance between the keys in the key value store, and then essentially manages a table within my copy of the DHT. So everybody's copy of the DHT looks slightly different, but what the distributed hash table then allows you to do is to very efficiently discover the actual IP address of somebody you look for. So once you connect to the Bootstrap server, you simply ask it, okay, here is the key. Who can tell me the IP address of this guy? The Bootstrap server says, I don't know. Who is the nearest guy to me who should know? Looks in his own key value store, calculates the distance between the thing you're asking it about and the keys it already knows about, looks for the nearest guy and says, okay, here are the 5 nearest guys in mathematical or in consistent hashing terms that you should really be asking, and here are the IP addresses. Then I go and I ask those 5 guys. And because of this 6 degrees or 3 degrees of Kevin Bacon problem that we all have, or benefit that we all get from in networks, right? You end up with a really fast lookup to discover the actual IP address of the person.
Of the person who can give you the value, is that?
Of the person who can give you the value, and then you ask that person, and then they will give you the value. Yes.
Yeah.
So you look for the person who has the value, and then when you find that person, you say, okay, tell me the value, and then they give you the value, and now I know what David's address is.
Right.
And it normally takes like 2 or 3 hops in the hash table in the DHT, at most like 2 or 3 queries before you actually get an answer.
So is like that actual DHT protocol and nearest neighbor stuff, like is that part of the core of what OverNode is, or are you describing the tooling that exists in other libraries that is the networking that OverNode is built on top of?
Yeah, so this is at the network layer. This is sort of this stuff exists in peer-to-peer libraries like libp2p,
yeah,
for example, or the Whole Punch project from Pairs. So in general terms, whenever you see a peer-to-peer networking library, they would all have a distributed hash table in it. BitTorrent, DHT. In fact, BitTorrent was probably the OG most successful implementation and usage of these distributed hash table functions, not taking anything away from Kazaa, eDonkey 2000, and those guys.
LimeWire.
Yes.
Yeah. So I guess, so why this this concept kind of intrigues me and I wanted to reach out and get some more information is because I've been working through this. Well, first of all, I've been working on a Go implementation of BSVA's kind of overlay services, which is tangentially related, I guess we'll say, as far as having nodes on a network that are all about, we'll say, kind of authoritatively knowing the state of a subset of the whole chain's transactions. And I've been kind of modeling out, rebuilding lots of different tools that I've built in the past into kind of a more overlay centric tooling.
Right.
And one of the things that I'm finding quite interesting and also not really solved yet is this idea of all these kind of like these different overlay networks that are essentially their own subsets of data, But then you start getting kind of breaking into, so I've got an overlay that's managing the state of a whole bunch of different fungible tokens. But as soon as I want to go to the next level that says, okay, I want to run an overlay that is swaps between this one token and this one other token. And so I don't need to know everything about that huge pool. But when something for that one transaction comes into this generalized token pool, the people who are caring about running swaps for those need to know when a swap has been executed. And so kind of there's this overlap between, okay, two networks both care about the same transaction, and users in either might be interacting with that token, that asset, and the other one needs to know about that thing changing. And so the kind of that whole graph of at some point, different intermediate parties that care about both almost start becoming a bridge between the two. And I'm not really saying anything specific here other than just this idea. And one thing I really love about modeling all this stuff on Bitcoin is in kind of the same way that IPFS has a great story to tell, because the identifier of a file is a hash of the file. And so that just brings all sorts of security. Like, you don't even really need SSL. You don't need so many of kind of the security things, because you don't have to trust that someone is giving you what you asked for. If it is if they didn't give you what you asked for, you'd hash it and it wouldn't resolve as the thing that you asked for. And so being that, like, in the Bitcoin world, we've got kind of this describing identifiers as what we use to identify things. It's really neat. And I totally see that there's going to be pools or networks or overnodes or what. There's going to be lots and lots and lots of different networks where people need to store certain things that also applies to other. And so I guess let's get on to kind of the economic side of this, because you talked about kind of
Can I say something quickly about what you just mentioned?
Yeah.
And maybe also tell you how OverNode solves the exact same problem that you described. Then we can go to the economics.
Yeah.
How does that sound? Okay.
Sounds great.
I was talking about the distributed hash table for a second, and also the fact that I'm using libp2p under the hood for it. Now, there doesn't exist, because my preferred language for implementing all of this is actually Dart and Flutter, so that I can get cross-platform mobile development sort of out of the box. You can build native binaries with it. There didn't exist until now, I guess, a libp2p library natively written in Dart, and I tried to bolt on the Go library for libp2p, and it will load, and I can bind the dynamic. I can link the dynamic link libraries on both platforms. But on Android in particular, they changed something specific about the way in which native libraries are meant to consume network sockets, and that is completely incompatible with the way in which this framework called Go Mobile that does the translation at compile time works. And I just basically ran hard up against the wall, so I decided, okay, I'm just going to port the entire libp2p stack to Dart, which I've now done.
Nice.
I'll release that as open source the moment that I've sort of managed to. Once I finalized interoperability testing, etc., which I'm not even looking at right now, but once interoperability testing with actual libp2p is complete, I will make an initial release of the full libp2p stack. But in this process, right, of doing this, coming back to the problem that you were describing about how to announce things in overlay networks amongst peers, you're essentially describing libp2p's gossip sub protocol, which is the idea that you have a pub sub within a peer-to-peer gossip network that you want to operate efficiently, because pub sub in general, gossiping in generally creates a mesh, but you want to create an efficient gossip sub which is topic based, meaning that not all nodes need to know about all the gossip they need to know about a subset of the gossip related to the topics that they're interested in.
Yeah.
So within the P2P gossip subnetwork, you end up with a subset of nodes who only gossip amongst themselves about the topic that they're actually interested in.
Yeah.
And so in your case, I can basically think that these bridging nodes would gossip about both topics.
Yeah, exactly.
And they would get to know about both of these events. The event would get announced on both, or they would have distinct events which they can then bridge. If they see one, they send the rebroadcast, do processing, rebroadcast, etc.
Yeah.
And it's essentially the way that it operates within OverNode as well. And because I'm using the P2P, and I actually moved to the P2P from Hole Punch, because Hole Punch worked. It was the first thing that I actually got to work reliably for sending SPV back and forth. But I ran into other problems with Hole Punch that I won't get into right now. But I'm actually glad that I went the P2P route, because this whole process of porting it has taught me a lot about the way that the P2P stack operates. And because of the way in which the P2P essentially layers its protocols internally, going from the transport layer all the way up to the application layer within the P2P stack, and how you systematically upgrade yourself through the protocol layers until you get to the actual application layer protocol or topic or gossip that you actually want to participate in, right? Really, really like it, because it operates a lot like what in the regular web server terms would be called middleware, or in Java terms, a servlet filter, right? In Node.js, I believe it's called middleware. The term middleware is also used in things like Rails, Ruby on Rails, where when you get a HTTP request into your web server, it gets handled through a number of different components in the stack before it actually gets to the HTTP handler, which is your code. And these intermediary steps can do things like check for the authentication headers, etc., right? Inject environment and do a whole bunch of other things before the HTTP request lands, where you can
check for payment. Yeah.
And so you can check for payment directly in this P2P protocol stack. So I've built a specialized SPV layer into it, so that if I want to ensure that I take an SPV payment from you before we do anything else, you basically get stepped up until you hit the SPV negotiation. SPV negotiation goes through, you exchange a authorization token, and then it proceeds. And now you're talking in the context of, okay, I've already got paid. What would you like to talk about, right? And it's sort of a natural fit for the P2P stack. And because you're working in Go, and Go is also the reference implementation for the P2P, I think it would be a natural fit. But I'm not going to say you should. Maybe you already are.
Well, actually, so this is there's been a fair amount of thought over the course of the last 2 years on kind of a different, from my standpoint, it's mostly been the peer-to-peer network technology is out there. There'd be some peer-to-peer library that can be plugged in. I'm not working on recreating peer-to-peer, but from the idea of saying I am on various my device, whether it's through OverNode, whether it's through something else, my device is on a number of different kind of maybe they're pub sub channels, a number of different things that I am listening to, and I have peers that I communicate with on those topics. And then going back to the idea that says, okay, especially let's use the context of social media on chain. So something like Tree Chat.
Yeah.
And in Tree Chat, you can have, so obviously you are making a post. That post exists in a Bitcoin transaction. And so my wallet, my device, my whatever is going to store my posts. If I want anyone to ever see it, I'm going to be seeding that thing on the network. And so as soon as you get to the point where other people are then resharing my posts or are liking my posts, there's an opportunity for those other people on the network to also be seeding those transactions. But obviously they don't have to. And in this peer-to-peer world, obviously things can come and things can go. And now if it existed on chain, in all likelihood, someone has it somewhere, or else the network can't spin up again. But that doesn't mean that it's going to be someone who's quick and close and easily available. But as soon as you start throwing on some incentives that says, okay, my friend reposts someone else reposts that, whatever. This network gets to a point where no one immediately has the transaction, but they do have a transaction of someone sharing it, pointing to that, or kind of a quote tweet maybe. It's like, okay, they're putting their tweet that references this other thing, but no one in the immediate network has that. So I've played around with a number of different ideas of like just smart contracts that essentially you can lock up funds in a UTXO that transaction then is kind of broadcast amongst the peer-to-peer network of saying, I want this transaction. Here's how you contact me. Here are the funds that you will get paid if you can deliver this. And then essentially the first person who can fulfill that contract, and there is a slight negotiation piece of people need to be online in order for this to work because you need to sign off from both sides. But still, the request for that missing asset actually includes the payment in order to reimburse someone for the asset that you're asking for. And so there's some really neat stuff once you kind of get to that next level of, okay, now I might not keep all of my friends' historical posts and whatever, but if there's things that I really like and that I have been part of its virality or whatever, and I want to be able to host that, but I can also get tiny micropayments by simply being a seeder of that transaction rather than just letting it go by. And in some ways, like the act of liking in a social network can actually imply that by default you are hosting this thing. And like that like can actually be triggering your software that says, keep this. And then at some point, if you want to unlike it to clear up your cache and whatever, great, you can do that. But
So yes, this is there is a lot of overlap with the thinking that you have and the things that I had to do in order to solve pretty much the same problem that you have. Like we're getting into the economics of it now, right? Which is how do I ensure I would like a couple of guarantees. They don't have to be strong guarantees, but I would like some options within my data plane. You've described one of them, which is I would like a notion of the liveness of the data to the extent that somebody somewhere would hopefully be incentivized to keep a copy of something around for a little while at least. Because to the extent that not everything is equally valuable in terms of what people would like to retain, maybe I can incentivize a retention policy, or maybe people will just opportunistically decide to have a deep retention policy themselves. On the off chance, they might earn a few sats from some obscure data, right? Because otherwise, you're just taking up disk space. Yes.
Yeah.
Now, there are a couple of things which you touched on when you were talking. One of them was the discoverability of the information. Within OverNode, the way that I solve discoverability is essentially, again, this whole stack of, once you understand how the distributed hash table works, and how then on top of that, how the pub sub gossip layer works, which sits on top of the DHT, then you end up with this notion of topic-based replication of information. Or I can at least say things and broadcast certain bits of data into the network, into a subset of the network, to other members of the network who are subscribing to a topic. Now, what can I layer on top of this idea of gossiping on a specific topic in my case, I decided that I'm going to gossip this thing called a Merkle CRDT, Merkle-CRDT. And these are two things. It is a Merkle tree data structure combined with a conflict-free replicated data type. And the idea of a CRDT, in functional programming terms, I think you can think of it as a way of combining, as a combinator. The CRDT is a combinator. It has a notion of combining two things in a way that makes sense for the underlying data type that it is actually combining them of. To give you an example, in a real world example that would actually make sense in the context of what we're talking about. If my CRDT is essentially or my Merkle CRDT is essentially a feed of all of the items that I have essentially blogged, all my microblog items. So all my posts that I sent out to Twitter is in my one CRDT. Let's call that my outbox CRDT. I would like to replicate this to a bunch of other people, but I would also like to have other people create a merged view of their own outboxes and their own inboxes, which means that Stefan subscribes to David or Stefan follows David, but Stefan also wants a merged feed, which is his posts interleaved with David's post in a single view. And this notion of then being able to create a consistent view, an eventually consistent view that looks the same for David and for Stefan, because it respects the time ordering of things, essentially is what you achieve with the Merkle CRDT. And all you have to do is broadcast the individual CRDT packets because they have all of the information that is needed for the Merkle CRDT algorithm to be able to reconstruct the local view of what is essentially an append-only log. And it does this in a way that doesn't need strong consensus like what Bitcoin does, because it doesn't have double spend, doesn't need double spend protection. Yeah. So the deduplication and time ordering can have less strict guarantees. You can use things like vector clocks, etc., to try and deduplicate and create a notion of time ordering or causality. If I comment on your post, it's obvious that my node in the CRDT comes after yours because one is causally linked to the other, right? Things like that. So Merkle CRDTs are a fascinating subject. Somebody else figured it out long before me, and there are a few implementations of them out there already. I believe that Hyperswarm in the Hole Punch network, for example, uses, I believe it's Hyperswarm, uses HyperDHT or Hyperswarm, one of these two, because the Hole Punch network normally has a name for a thing, but then there are a whole bunch of functionality tacked into it. Yeah. So they conflate concerns, which was one of the problems, not problems, but one of the issues that I had with it, because you kind of try to tease the DHT isn't just a DHT. It's also an append-only log, and it's also this other stuff. Right. Anyway, yeah. not to rant about that.
I just pulled up an article on these so I can read it later. So,
yeah. All right. So now that I have this notion of how to actually do this, the replicated state using this Merkle CRDT data structure, each of the items in there is also identified with the content identifier, which we spoke about earlier, which is a unique identifier that globally identifies this item within the namespace of items that exists in your overlay network. And which means then, if you go back to this notion of discoverability that we talked about, you can ask somebody through the DHT for the content identifier that you're interested in. You can discover who still has it, and then you can step up through this libp2p negotiation, hit the SPV payment, and then download the content from them, which then goes into your local CRDT, gets appended in there. Or somebody might altruistically just give it to you, right?
Yeah. Your friends might share posts with each other or whatever.
Yes. Yeah. The idea of and this is the idea behind the store and forward services in the OverNode network as well, is that they are not there to replace the notion of direct peer-to-peer connectivity, but direct peer-to-peer connectivity requires a coincidence of people being online, sharing the same content at the same time.
Yeah.
And if you're talking on mobile phones, then you have very weak guarantees about people being online at the same time.
Yeah. Or even being able to find each other, even if you are online at the same time. Yeah.
Yes, because we're either geographically distributed or we have really small groups. So you have fewer opportunities for coincidentally. Now, if I am a YouTuber with 1 million subscribers or an Instagrammer with 1 million subscribers, chances are at any one point in time, maybe 50,000 people are online at the same time. So I'll always have liveness of the data. But if you want to have stronger guarantees than that, especially for smaller groups of people who are sharing data, then you probably want to have the assistance of something like a store and forward server to help you out with the liveness of the information. So, hence that.
And I guess it's kind of so. This obviously applies very much to Bitcoin stuff, but also has nothing to do with Bitcoin at all. So I guess where do I want to go exactly with this? I guess, first of all, when it comes to the OverNode network, like where is your path toward getting to a point that developers can build things that plug into it? Is it about releasing some open source libraries, or do you first need to solve some of the economic problems? That's okay. There needs to be a mechanism here where we can have some incentives to seed these things or to store and forward. Kind of what's the path forward to where you want to start opening things up or having people use this? Yeah.
Which brings me to another reason why I thought that libp2p was going to be the better option for moving forward, because there are just so many more libp2p implementations out there, which provides more opportunity for other people to use their favorite programming language to start interacting with the OverNode network. Now, obviously, within the OverNode network, there are a lot of specialized and OverNode specific protocols at the application layer for things like what are the messages that you send back and forth for an SPV negotiation. Yeah. Some of them overlap with beef and bump and some of the BSVA standards. Some of them don't, fundamentally because of the way you're not operating within a request response protocol like REST. It's a different request response peer-to-peer protocol in a different network layer. Which also means that probably you want to prefer using something like protocol buffers, which are tinier, smaller on mobile devices than JSON, which creates larger data packets, right?
Yeah.
Raw
transactions.
Well, a raw transaction looks a lot like a protocol buffer, you know?
Yeah.
Sorry, I lost my train of thought. I was talking about. We're talking about the economics.
Well, I was just kind of asking. Yeah, it's kind of the path forward. Like, what are you?
Right. Yeah. Right. So I will release the libp2p stuff, and then I will release the actual protocols. I will document them and create some interoperability guidelines that would allow people to use it. At least the store and forward server will be open sourced as well, so that folks have a reference implementation for the store and forward server, and the Bootstrap servers will be open sourced. The mobile client itself, I don't have any intention at the moment of open sourcing that, but I do intend for all the protocols for how to interoperate and effectively communicate with each other in the network to be open source.
Well, then let's actually go a little further on that, like the mobile client. So like we've talked a lot about just kind of the network layer of how things are done, but we haven't actually talked that much about the what. Like what is in the mobile client? Like what is it? Is it essentially well, yeah, how about just let's start with what is it? What do you do with it? What
So the mobile client, we already kind of should at this point have an idea that the mobile client has a libp2p stack built into it, so that it can form its own peer-to-peer overlay network, essentially, for other mobile devices to be able to discover each other. What it also has, in addition to that, is a native Bitcoin block headers client, which directly connects to Bitcoin nodes on the network and is actually a first-class peer on the Bitcoin network. So it speaks the Bitcoin peer-to-peer protocol natively as well. And so the mobile client, in that sense, bridges itself into the Bitcoin network so that it can get real-time block header announcements from Bitcoin nodes at the same time as it is forming part of this overlay network of its own construction, right? And so that is the sort of the primary point of departure for how this thing exists within the internet. It participates in two peer-to-peer networks, and one of those peer-to-peer networks allows it to essentially do SPV, micropayments, etc. The other one allows it to exchange information, data, and the combination of the two allows you to create a monetized data economy, essentially.
But as far as so like when you talk about your app, I assume that's going to be kind of like several apps that take advantage of this environment, or is it really just about kind of being on the network and storing data to be part of the network? Or
so it is one app at the moment. It's like one super app that has everything in it. It also comes with a wallet.
Yeah, of course.
The app is a number of things, and I'll also talk about the way in which I've tried to make the app extensible, and essentially try to create a plugin ecosystem within the application. There are a number of things which I thought would be beneficial as a first release to both prove out this idea of the data plane that exists absent server hardware that I run in the data center to keep the app alive. So there is no Supabase, there is no Firebase or Firestore behind my mobile app. Everything is just local, which means it can be private, means I can encrypt things and do all of the cool things with end-to-end encryption that you can do when you don't have to share data into a server that needs to have at least enough information for you to connect to each other so that it can also then, harvest your data. Which, and I want to say also that while I am a privacy advocate, and while I believe, I don't like the fact that our data gets harvested, I'm also, I didn't build the application, and OverNode wasn't built as a privacy tool either. It was sort of a coincidental consequence of the way in which I was architecting it, that I ended up needing to solve security problems, which ended up just creating privacy inherently as well. So the privacy of the application came about as a consequence of trying to ensure security around the application, in the same way that if I was going to communicate with my bank, then I want to make sure that the bank has a proper SSL certificate for their website, and that TLS 1.2 or 1.3 at least is active, etc., right? From a developer standpoint, those same types of security guarantees that you want to have to protect the user who's using the application, naturally then, because this is just a peer-to-peer network, means that everything is just private at this point. Because if you and I create a transport level, a TLS level, TLS security, a transport layer security connection, a TLS connection, in the case of libp2p, it's actually a noise connection, but it has the same consequence.
It's a peer-to-peer encryption based, or
one-to-one.
That's
the point-to-point encryption essentially. Then now we're talking to each other privately, right? And if we are going to do store and forward in a way that I want to make sure that we can have a private conversation, okay, maybe I should use something like Signal's double ratchet protocol, where you can have a store and forward server facilitate the movement of the messages, but the store and forward server can never actually break into the conversation itself, and you have perfect forward secrecy. So even if one key is compromised, past and future conversations, parts of the conversation are still perfectly secure, which means any group member who tries to compromise the group can't really do so, with certain caveats around that as well, right? So the privacy aspect ended up being just a consequence of good engineering, in my opinion, rather than a primary driver for okay, I want to save the world and everybody must be private and the government or whatever. It just so happens that if we construct peer-to-peer networks in a way that respects people's privacy, then you end up with something like what I just described.
Yeah, and that's most of my focus recently has been on kind of the exact opposite of that, of stuff that is by intentionality not private and is attested to by I'm kind of publicly attested, such that a lot of stuff recently when it comes to like on-chain social medias where the whole point is I'm getting signatures on public posts because that person is building up their own presence and their own reputation based on publicly proving the different activities that they do. And so it's really how that starts leading to the idea that says, okay, you're not using Twitter's algorithm or Facebook's algorithm or Instagram's algorithm. You can actually separate the algorithm from the underlying data itself, and you can even run the algorithms yourself to say, okay, I'm going to weight things that my web of trust of friends have liked or shared above things that someone, and then I can go through and add in other different layers. That's okay. I want to use this kind of ranking algorithm, but all the underlying data all speaks the same language. It's all out there. But when you start getting to then that same exact universe of data can be sliced and diced 900 different ways in 900 different networks, and all of them are going to have different subsets of the whole. It just it's a really, really cool, simple yet powerful universe we're entering into. And especially as you get into, so I don't know how much you've played in the AI space at all. I've been very hesitant, but I will say in the last couple months, I'm starting to kind of get the vision at a level that doesn't terrify me as much as it did before, and starting to really realize how much, like, we're not very far away off from the things that are running in the cloud right now with these monstrous data centers and monstrous things. We're not very far away, two generations of hardware away from you being able to run a 400 billion parameter model on your own local computer. And then you start working through, I I've been using Claude Code for the last couple of weeks,
Yeah.
which takes an entirely different concept of like at least how I was gleaning how things like Cursor tend to work. Of when you kind of add different code files into your context, it basically just makes this huge context that includes all your referenced files. And well, Claude Code kind of takes this a different idea on it, where it's basically mostly instructing your CLI what commands to run to analyze your data to get a very small and tuned context that it will then and then you've got this idea of these MCP servers, which I'm brand new to at all, but they're basically modular functionality that says, okay, my agent that I'm running locally eventually within a few years is configured to be able to consume external tools from external places that other people are opening up. And just a couple days ago, kind of this realization struck me of how much kind of even this whole agentic AI crazy future we're in can still kind of boil down to all these peer-to-peer connections. That's not, I'm plugging into the scary cloud, but I'm plugging into the agent or the service that you're providing, and that this company over there is providing. And so you end up with both from kind of where we're talking about here, the data and the payment stuff being very much peer-to-peer, but also kind of the compute becoming peer-to-peer and the AI services. And so this whole decentralized communication layer, and especially as you get the economic system built into it, is, I mean, it's crazy to realize how it truly decentralizes our world in a way that it isn't about, like you said, Stefan's not running an overlay node but there are things that are, but you're just up here on the network, and a transient network that comes and goes, or that members come and go, but the network lives on. It's very neat.
Yeah. A big part of that future you're talking about is already here. We already have mobile-focused, small, like 2, 3, 4 billion parameter models that can run on mobile.
Mm-hmm.
Facebook has released a version of Llama CPP that is slightly tuned, that essentially runs a quantized version of a model. I think it's an 8 billion parameter, quantized 8 billion parameter model that will run and only consume 400 megabytes of device memory, which is perfect for running on mobile devices. Google has released Gemma 3N, which is the N stands for nano, which are, I believe, 1.8 and 4 billion parameter models, which again can run on mobile devices and are squarely targeted at leveraging some of the AI chips that they've been talking about that sits in these things, which are really there for inference, can also be used for model execution and assist the GPU as more of a specialized thing in the GPU execution to essentially allow you to execute these models as well. So yeah, the notion of running a 400 billion parameter model on your mobile phone seems outlandish now, but it's a matter of time as far as you're right. I fully agree with you. It's a matter of time.
Yeah. So it's an exciting world. All right, we've been going for about an hour. Anything else you want to dig into, or shall we wrap it up?
Well, I maybe want to mention we didn't really talk about the plugin ecosystem for OverNode, and I want to talk about that because it's also something that I think is a great way for other people to start exploring interoperability in a different direction.
Mm-hmm.
The plugin what I've experimented with, and yes, I'm also embedding like these. I'm playing around with it with embedding, or when I say embedding, my brain is crossing wires with these notions of embeddings in machine learning, LLMs, and I'm playing around with the notion of embedding um, a machine learning stack inside OverNode. At the same time as I'm playing with the notion of embedding a full-on LLM like Gemma 3N or the Llama CPP small versions inside, and thinking about what can you do with that. Now, I think that in and of itself, these things won't be particularly useful, but I don't know how much you know about WebAssembly.
Yeah, I've done a fair amount of research into it. Yeah.
Right. So the best part about it is that you can very easily create a WebAssembly runtime and tie it into your mobile application, which I've now done. So I have a WebAssembly runtime that essentially is bolted into the OverNode mobile client, which means that it opens up the possibility for anybody to distribute a binary executable that can run sandbox inside OverNode. And the only thing that then has to be figured out is what does the display look like and the user interactions for the underlying thing. I can either standardize it or I can extend the sandbox WASM backend with a web view that again opens up in the mobile application. And now you have a locally running backend for your own web application that sandbox inside a web view.
Browsers all the way down.
Exactly. It's browsers which will sound funny to a lot of people who've been hearing me say leave the web behind.
Yeah.
So I'm eating the web at this point.
Yeah, leave it behind by by building it in. No, I've actually done. So in my last 6 months or so working with crypto fights, I started doing a lot of looking into kind of, I guess I would say, publishing authoritative virtual machines for games on chain, written in WebAssembly in such a way that, like what we're doing with some of the ordinal stuff, where essentially it's just an on-chain reference to get the actual thing that's there. Well, then having a runtime or essentially a server that you're configuring by literally pointing it to different transaction IDs, which are the kind of self-evident authoritative code that runs that version of that whatever, and then be able to kind of basically, I mean, it was very similar to what we're doing with kind of how the overlay service is mapped out of configure. They've got configurable topic managers, which are, I mean, it's the same kind of thing of just like this dynamic stack of these are the engines that you're going to run your transactions through to kind of perform any state manipulation or whatever else. But they're just a modular piece, and it's pretty cool, powerful stuff. And I can't wait to get kind of back in playing with that again, but it's always something to work on.
No, I think that, and I said on Kurt's show, right, that I basically want to push the mobile phone until the wheels come off. And I was deadly serious about that. As you can tell, I'm throwing machine learning models, ML models, LLM models, WebAssembly, runtime, all of these things into it, just to see what happens, right? Some of it is okay, some of it seems not okay. I still haven't gone through the Apple review process with the app, because I don't know what they're going to make of this monster of an application when they see it come through.
That's true. I haven't actually thought about that, but WebAssembly does kind of allow some. I mean, I guess it's still limited by the sandbox of the app, and then therefore, but it does allow dynamically generated code essentially to run, which used to be a big no-no in their world.
Yes. Well, Safari, I'm hopeful because Safari on mobile apparently does come with the WebAssembly runtime itself these days. So it's not like they're completely. I think WebAssembly is mature enough at this point, and the sandboxing has strong enough security guarantees that even Apple is happy with the sandbox for the WASM runtime.
Yeah.
So I'm excited about it.
So yeah, basically, I mean, if you've got a browser in your WebAssembly in your in your OverNode, and then you can load up other ones of those, obviously. Then it just becomes an issue of what interfaces are you kind of injecting, or are you making available for it to read data out? Well, I guess if it's a web browser, though, it can actually reach out.
Well, the idea with the web browser for me is that I probably want to be careful about the web browser reaching out to the internet. The web view itself, I want the whole thing to be entirely self-contained. I don't want the web view to be able to reach out to the internet.
Yeah,
I want all the assets and things to execute locally within the web view, and any communications will be brokered essentially by making internal API calls either to the wallet or to other running applications or other ways.
Yeah, that makes a ton of sense. So if you need to find the state of the Bitcoin network, you've got an API to get the block headers. If you need a query, or if you need a view of what your UTXO set is, which obviously could be, that could be anything from tokens to encrypted state to whatever can live in those. That makes a ton of sense.
And I'm essentially building the application in hard mode on mobile, but I'm also doing it in Flutter, which is Google's ubiquitous computing platform. It is a small hop from the mobile instance to the desktop instance, and it's just another hop from the desktop instance to the instance that's running on your television set.
Yeah.
The next thing definitely that comes after the mobile phone is to build out the user interface for the desktop version, because it will all use exactly the same underlying bits. It's just a matter of making sure that the layout makes sense for desktop clients, and then it can be cross-platform. It can be Linux, Mac OS, Windows on the desktop, everything.
Yeah, and that's one thing where rather than creating your own layout language or something like that, using the web is great. I mean, that's obviously a problem that developers have spent the last 15 years perfecting, of how do we respond, how to make these things responsive, and
which is also my biggest complaint with the web, is that the web threw out everything that Microsoft accomplished by giving us standardized UI tooling for building desktop applications and started over. And eventually we're converging back again to, okay, let's just use Flutter or Cocoa or standardized user interfaces.
Did you ever use .NET Web Forms back 20 some years ago?
I escaped the Microsoft ecosystem right before .NET, so I'm very glad I didn't.
Yeah, I stuck around for a few years into that .NET thing. Yeah, it was basically kind of taking the Visual Studio, the old. It was a nightmare. Basically, there was a one state variable that just kept getting posted back and forth every time you did anything, and it would just grow and grow and grow. The more, anyways, worthless.
Yeah, I built native Windows desktop applications pretty much from 1992 until 2001. That was sort of my bread and butter. So I became very deeply familiar with DOS first, and then Windows 95, the Win32 APIs. First, the Win16 APIs for Windows 3.1, and then the Win32 APIs for Windows 95, and then the web became inexorable in the early 2000s, and I went into
all the glory of PHP and Perl.
Yes, my very first job in Webland was a combination of Java and Perl. So there you go.
Yeah. All righty. Well, thanks, and I appreciate chatting and kind of getting me up to understanding of what we're even talking about here, and look forward to chatting again in the future.
All right.
All right. Yeah. Talk to you later.
Bye-bye.
Bye-bye.